Welcome to the VMware Multi-Cloud Podcast. My name is Eric Nilsson, and with me today I have my co-host, David Jasso. On the show today, we're going to be talking about event streaming architecture, machine learning, and vSphere. David, how are you doing today?
I'm doing well, Eric.
Fantastic. Well, really excited to have this topic on the show today. It's very current, machine learning. So, David, why don't you introduce us to Justin and take
Sure. Hey, Justin, glad to have you today. Hey, Justin, we usually start off with giving the audience a bit of background on the guests. So maybe you can walk us through some of your history. You and I have known each other for a long time, going back to a period where we both worked at HP. But maybe you can just tell us about your role at VMware, but also just some of your history in tech and some of your roles, your other roles as well.
Thank you, David. It's great to be here, and thank you for inviting me along, Eric, as well. It's great to talk about this subject because we're really talking broadly about modern architectures. But I started off at VMware in 2007 working on Java, sort of a common element for lots of applications. And I'd come, as you know, from Hewlett-Packard, where we did a lot of J2EE work before I got here. And so my first job at VMware was making sure that BEA worked on VMware and that all our customers were happy to do that. At that time, that was the sort of common platform that everybody was interested in. And it got acquired by Oracle and is now history. But that was a very interesting couple of years testing that out and proving out that Java, or a platform that many applications could use, was working on vSphere. That's kind of a theme, I think, in my career, because we're now doing the same thing for Kubernetes. And even before Java, there was Linux. So
I know your role really has been around sort of looking at leading edge technologies for that time, whatever period that was, and how to best optimize vSphere for them and making sure things worked. You did some other things too, right? I think I remember sort of running into you early, and you were doing some work on big data when that was a thing, right?
That's right. I moved on from the Java work to Hadoop when that was very, very popular. Actually, Hadoop is still in use and still mentioned in modern architectures, but we synced up with the major Hadoop vendors to prove out that big data platform, data warehouse is what we call it now, I guess, so that we were actually running 100, 120 machines in a single Hadoop platform at one time. And that kind of led me naturally into machine learning, because what are you going to do with all that data? Well, you'd like to report on it, business intelligence type of reports, which is what Hadoop is good at. But you also want to sort of predict what's going to happen next from it, and take all the credit card history that's been lodged in data warehouses and try to predict what Justin will do, one example will do with his credit card next month. So I've been extremely lucky to work on all these emerging technologies. I've had a great time working on these. So
more recently, I talked recently, and I think we caught up a couple of years ago, and you were working on, sort of modern. You were really moving to modern architectures and looking at technology in that space. Specifically, I remember you were starting to do some work around Kafka, and that really brings us to this topic today around event streaming, and also everything that it takes to do that well. And maybe you can tell us about some of the, and again, we'll get into the details in a bit, but just sort of introduce the more recent stuff you've been doing.
Sure. Yes, we absolutely did pay attention to Kafka, and it's a very pervasive thing. It's event streaming, message bus type of technology. When you talk to the leading player in this world, Confluent, they're very aware of modern architectures as a whole, because they're everywhere. They're in Facebook's architecture, they're in Uber's architecture, they're in Netflix's architecture, they're in all contemporary modern technical application architectures. And so we wanted to.
Yeah, I was going to say, I read somewhere that 60% of companies have some event streaming platform as part of their business. And, and maybe you can just sort of, do a couple things here. One is articulate, what some companies are doing. I think about things like Uber Eats and, that case, and right. Also Netflix. And then kind of we can start to talk about, flush out what that architecture looks like.
Yeah, I think this is a symptom of live data coming into companies from the outside at very high rates. Like you can imagine if you're inside IT at Netflix and you're handing out video streams to people at nighttime, there's a whole lot of feedback coming back to you, not just reviews, but how is the streaming doing? How is the speed doing to all these destinations? And what is the quality of service that people are experiencing? And those are all coming in as events, and they're coming in through various channels, but they're coming into Kafka as the manager of those events, because Kafka's got brokers for receiving events and putting them into different topics and then querying on those topics in the same way that you'd query a database. But where in the past we had a sort of data warehouse composed of tables and files, and we read from it and we deliberately fetched the data from it in a batch mode. In event streaming, you're in real time. This is thousands or millions of real-time events arriving at your doorstep. What are you going to do with them? You need some kind of pipeline to put them into. And so all of these contemporary architectures seem to have two main threads to them, a sort of data warehouse, rather batch-oriented thread, and a live online event streaming thread, which is coming in at high volume. And so Netflix is doing that to prove out quality of service, to watch what's going on with the downloads that are happening of videos by people. And they're receiving events back continually to tell them what's going on. Uber Eats is a great other example. They're wanting to predict delivery times based on traffic patterns and what's the reliability of that vendor of food, for example, or what are the typical delivery patterns for that destination, for that part of the city or part of the countryside. All of this is coming at them in event streams that are feeding into Kafka, and they're using that to make predictions about how long it's going to take to deliver Justin's dinner tonight to his doorstep. So
Yep.
This message event streaming live data paradigm is getting to be pervasive now in modern architectures, alongside actually the old data warehouse method.
And they're doing this with microservices and running these on top of Kubernetes infrastructures and those kinds of things.
Absolutely. Containers are pervasive now for this too. Yeah. And Kubernetes.
So, recapping that from an architectural standpoint, you've got event streaming and a capture process. You've got the data side of this, which is data warehouses, data lakes, those kinds of things, because you need to keep track of tons of data. And then you get also into the newest area you're involved in, which is machine learning. You've got to figure out what it all means and then do something with it, right?
That's absolutely right. And those two streams that I talked about, the sort of batch-oriented data warehouse stream and the event-oriented stream, both are providing data to some algorithm, some trained model, or to train the model itself, which is a term we use in machine learning, which is to feed it with historical data, get it educated on what the patterns are, what the important things are in it, and then either classify an event that's newly arrived or predict what events are going to happen 10 days from now or 5 days from now based on various criteria. So that whole theme of prediction has really emerged over the last 2 to 3 years, which is what machine learning is good at. Once you've trained up a model with historical data, the real payoff for you, the benefit to the business, is prediction.
Right. Hey, Justin, I have a question before you go too far into this. Like, I want to come back a little bit and go, like, from me having conversations with you and a couple other guys in this field, it's not just the Netflix and the traditional streaming that we think of, but it's also it's building management. It's so many different apps, like between Tesla cars and building management and all the things where you get, IoT data back as well, where it's almost like if you're building any application nowadays, you have to deal with this large amount of data coming in from whatever your business app is that's out there.
You're right. And, the event streaming people think of the world as a series of events that never stops, essentially. That's a big difference from taking all your records and putting them into a database. The database is almost a snapshot in time. When you update the record in the database, you don't see all the past history of that record. But with events, you're seeing all the past history as well as what's happening now. And IoT that you mentioned, Eric, is a great example, because here are all these sensors everywhere feeding events to somewhere. well, they need some control over that feed. You know, what are the topics that those events refer to? Do they refer to temperature or pressure
Right.
or what? Air sensing. Those are coming in live all the time. And, you know, the theme of event streaming is you don't want to stop and pause and have a record in a database that's static. You
Right.
want that, but you want it as a secondary thing. The eventing is like a database that never stops updating.
Right.
You know, that's
And then the machine learning comes into play, which is what you're going to go into, I assume, is this notion that we can do predictive analysis of, if I see these 30 events, I'll know that the next 50 events are going to happen, and then after those 50 events, I can also predict that your building's going to burn down, right, or whatever it is that you're going to have to deal with, and it becomes, you know, part of your major service.
Yeah, exactly right. And, you know, a fairly well understood example of this now is, given all the credit card transactions that people like Justin or Eric have done for the last year, given all those either in a data warehouse or in an event stream, can I feed those to a model to have it understand what the patterns of credit card behavior by Justin or Eric are? And we're either similar or we're not. And now that it understands our patterns, can it take David and say, is David a good bet for a credit card, or is David likely to default on his credit card? Even though I've never seen David before, I know his characteristics, his zip code and his salary, and you know, his job.
Oh, I know he knows Justin. He must be a good guy.
Right. So
And
it seems like the microservice architecture that kind of built up the ability to scale in, like doing, you know, events control, was just step one in what I see now is this expansion into now that I have this real-time event capability, now I start building this logic on top of it with my models. It feels like we're just getting started enabling, you know, better services.
Absolutely, absolutely. And what we did with Confluent was, as you know, in the past year or so, the pace of interest in Kubernetes in the outside world and in VMware has really ramped up. You know, we're all over Kubernetes now. We're doing Kubernetes with everything. It's built into vSphere. It's built into VCF. It's built into every cloud that we're working on now. All the clouds, the major ones: Google, AWS, Microsoft. You know,
Yeah,
we're
just
there.
so I can clarify, the VCF is the VMware Cloud Foundation.
VMware Cloud Foundation, which is the combination of the core vSphere plus vSAN plus networking. So that's become the leveler now in my mind. Kubernetes has become the leveler across on-premises, virtualization, and the multi-cloud. So, you know, we used to talk about the SMAC stack, SMACK, Spark, Mesos, Akka, uh, Cassandra as a database, and Kafka, K for Kafka. Well, Akka as a language didn't really become pervasive, but Spark and Kafka both become pervasive. They're both containerized now, and they come as Kubernetes deployable things. You know, even your infrastructure software, your software that you're going to be using in your applications is now being delivered by the vendors in container form to be deployed on Kubernetes. So it's a real leveler across all of these different platforms that make up the cloud, and VMware is part of them.
Yeah, and this gets to how your role has changed, right? Because when you started, you were thinking about vSphere, even though it was emerging tech, it was pretty much traditional stacks, right? I mean, we're talking about traditional VM stacks, and now we're talking about making vSphere the best platform for containers as well, right? And so that's where the Kafka and Confluent stuff comes in, right?
Yeah, that's a good connection, David. The job I took on last January or so was proving out Kafka in containers on VMware vSphere and doing it on VMware Cloud on AWS at the same time, which is our first cloud. Confluent, the big company in the Kafka world, has something called an operator. And an operator is a way of deploying things on Kubernetes and managing them on Kubernetes. And so we were very attracted to proving this out to begin with. And that's a project that we did at the beginning of the year and put out a blog on it to prove out that, you know, Kafka, among many things that you would be using in a new microservices application, works very well on vSphere, and you can deploy it on Kubernetes on vSphere or vSphere with Tanzu, and do that on the private and the public cloud equally well. So that was a very interesting project. That was pretty much my first encounter with operators as a term in Kubernetes. And since then, I've discovered there are GPU operators, and there are MongoDB operators, and there are Spark operators. You know, everybody's building an operator now to deploy on Kubernetes in the same way. And so that's become a sort of paradigm now where you would deploy your thing, whether it be a platform like Kafka or a platform like Spark, onto vSphere in container form.
Yeah, it's interesting, David. I'll just mention here, watching vSphere 7 roll out, how all of a sudden overnight, or it seems like overnight in my time scale, which is like a year, all of a sudden everybody has Kubernetes. They just installed vSphere 7. Tanzu is part of it. They enabled Tanzu. And the next thing you know, all of their servers that they've upgraded to vSphere 7 just has this as a base, right? And all of a sudden everybody's coming into now machine learning, vGPU utilization, and they've just like rampantly scaled up to, oh yeah, we have that. Now how are we starting to utilize the next layer up, which to me is this stack that you're talking about.
Yeah, it's funny because I absolutely agree, Eric. I think, you know, we're continuing to sort of optimize vSphere for whatever the latest environments are in terms of applications, so containers and Kubernetes, and then, you know, bringing that all into the VMware fold as well. But it's also interesting because you know, more recently than even that, Justin, you've been very involved in what's going on with GPUs to support machine learning, right? And that's taking you down into the hardware infrastructure. Right
back to the hardware, absolutely. And it's amazing that so much innovation is going on at the hardware level still. You know, it's we thought when Linux became the dominant Unix that was the end of hardware innovation.
That was it, yeah.
But it's not. So you're right, David. For the past 2 to 3 years or so, I've been looking at GPUs and explaining to our customers how to do GPUs on VMware for machine learning. They've been around for graphics for years and years. People have been doing high-end, you know, a mechanical design AutoCAD with graphical applications on GPUs for at least 7 years that I know of. Since 2013, VMware's been supporting that. But the past 2 or 3 years or so, the community of machine learning people has discovered that GPUs do wonders for these complex models that they're building, which are a lot of parallel math inside them. And parallel math executes very well on parallel cores. And parallel cores is what makes up a GPU. So
right, versus a CPU, right, where there's just a lot fewer cores, right? I think that's the
exactly right. Exactly right. And that's the key thing about GPUs that makes them ideal for this. And so pretty much the first or second question out of most of my customers' interactions now are, okay, you want to talk, Justin, about machine learning on vSphere. What do you have to offer for GPUs? Because I'm not doing this unless GPUs are involved, because even the classical old-fashioned machine learning algorithms like classical statistics, logistic regression, XGBoost is a very famous model for this, for looking at, you know, salary data that's coming in rows and columns. Even those things are being accelerated by GPUs now, where 2 years ago, nobody was doing that. So we have a good story actually in this area on VMware and on the cloud as well, which is that you can do GPUs in 3 different ways on VMware, and you can choose between them or mix them together into the same environment. And I get into details with customers about that, but the overhead in doing GPUs on vSphere is pretty negligible. You're basically going as fast as you would on native in many cases.
And I know we're doing some work with Nvidia. There was a big announcement at VMworld about our work with them. Maybe you can chat a bit about, you know, what that's about, and because I know that's all about machine learning and GPUs.
Sure. From a business perspective, Nvidia and VMware have a lot to offer each other. You know, VMware brings the enterprise presence that it has had for several years now, and Nvidia brings that huge innovation that they're doing in hardware, but also in software. There are thousands and thousands of engineers at Nvidia exploiting that acceleration hardware that they build so well. So at VMworld in October, Pat Gelsinger and Jensen Huang, the CEO of NVIDIA, announced that they were going to get together and do something big together. And there are 2 main threads to that. One is around smart network technology, smart NICs, The term at NVIDIA for it is the DPU, the data processing unit. Essentially, it's about offloading some more of the CPU's work onto a smart NIC, onto a network card, high-speed network card with an ARM chip on it to do ESXi work, essentially, networking work.
Was that what was called Project Monterey? Was that the?
That's called Project Monterey, exactly. And the second thread to it all is, what are we going to do together about GPUs? And this is where I paid most of my attention. And NVIDIA is now shipping the perfect GPU for a cloud environment so that you can carve up that GPU into isolated pieces. And hand one piece to one tenant of your cloud and another piece to another tenant, and pretty much guarantee that they're isolated from each other. And that's a real innovation. They had sharing before, but there was no guarantee of that separation between one tenant and another. And so they're innovating along. That thing is called multi-instance GPUs or multi-tenant GPUs. But they're working very hard with us to certify all the riches that they've got in their cloud offering, which is called the NVIDIA GPU Cloud, huge collection of application-specific frameworks and trained models, to certify that on VMware, on VMware Tanzu, on Kubernetes. And here comes Kubernetes again. You know, as I dug into this NVIDIA GPU Cloud, I discovered that what's the canonical way of deploying something onto this? It's in containers on Kubernetes yet again. So this was music to our ears at VMware, because we've now got Kubernetes native on vSphere. And that's what we did as a first trial of that, is took actually a medical application and deployed it in containers based on NVIDIA frameworks onto vSphere with Tanzu, and showed that at VMworld. There's a recording of that out there that you can get a hold of.
That's cool. That's sort of, like I said, from sort of innovating up the stack with new application architectures and innovating down all the way into the hardware. It's pretty cool.
Now that you asked me about this history perspective, David, I'm beginning to see that Java, Linux, J2E, Kubernetes, they've all had the same theme, which is, what is the platform? What is the platform that we like today for everybody to use to build applications that will be swappable from one server to another? And what we're talking about now is swapping applications over from on-premises to the cloud and back again. And I think Kubernetes is the platform there. Definitely.
Cool.
Yeah.
Makes sense.
Yeah.
Eric, did you have any more on GPUs? Or I know you had mentioned machine learning and some of the stuff you've done before with Justin.
Yeah, no, I think that it's just a fascinating, march of technology where all of a sudden everybody is expanding. You sit on vSphere, you pick up Tanzu with Kubernetes. We now have GPU support, vGPU support, where you can start doing machine learning, and everybody has moved into the application, but yet the platform ties back in very tightly, right? Like, the whole platform is needed there. And then throw in the cloud and multi-cloud, right? And being able to then utilize excess capacity, and what AWS is doing around, offering up banks of, I think they're even doing GPU now banks, right? Do they do that as well? Yeah. Right.
All the big hyperscaler clouds have GPU capability in them, so that if you wanted to burst this workload to use 4 GPUs or 6 GPUs for a short period of time, these are expensive devices, and the instances are expensive. So you could use a public cloud for that. On premises, where we kind of start our journey, the 3 methods that we suggest to a customer they explore are: put the GPU into direct pass-through mode, which means the hypervisor is minimally interfering. Secondly, move on from there and put the GPU into virtual GPU mode, which means you can share a single physical device across multiple VMs, multiple users. And lastly, use all that GPU power over the network. Share it over the network. That's BitFusion. So all of those 3 mechanisms are out there today in product form, and are quite mature. And I was talking to a bank yesterday. They were saying to me, which of those do I choose? Which is the best performance? Because I want to squeeze every ounce of performance out of it. And the answer is, there isn't a huge amount of difference between direct path IO and virtualizing a GPU. at all. There's a couple of percent of difference. So
the other thing that I see here that's fascinating, because things, as you say, things repeat themselves, is that back in 2006, when we were, everything went single rack U units, the explosion of one rack U units were out there. And all of a sudden the virtualization layer came along, and, it was a mess to manage. You had 1,000 or 3,000 or 5,000 rack U units in your data center. And all of a sudden virtualization came and everything consolidated back. And you had like a nice turnkey, easy way to control all your virtual machines, where you didn't have to manage thousands of hardware devices in racks. You can consolidate it, and all of a sudden big servers with VMs and all the VMs running on there made sense. And so all of a sudden VMware offered the ability to just manage that complexity in one package. And I look at today's world, where all of a sudden we had Kubernetes, and we had the sprawl of Kubernetes and microservices and everything, and all of a sudden, with Tanzu in vSphere, that all consolidates back down to one turnkey solution that you can then focus on the upper level stack, right, where the complexity actually lies. And VMware's actually turnkeyed Tanzu into here's Kubernetes and a whole platform for you that also manages your vGPUs and everything, so that you can work at the higher level again. Right.
That's correct. And I see the Tanzu portfolio, or family of things, if you like, as satisfying the needs of the developer, because the developer wants the Kubernetes APIs and the Q control command and Helm charts to deploy things. And they speak that language, and the developer likes that language. But the community that we've spent a lot of time with is system administrators, system operations people. They want security and regularity and stability, and we're offering that still, while giving the innovation to the developer community. It's really a joining together of those two forces. I've used Kubernetes in the past few weeks in single node mode, just one virtual machine with one node of Kubernetes, and that satisfied my need, because all I want to do is deploy something small. But clearly, when if ever that got into production, or even into pre-production testing, we'd need to test that on a bigger scale thing, and we'd need to scale up our
and I'm not even sure developers really love Kubernetes. I think they love the machine learning and the things that you build on top of it, but they needed it. They needed that platform. But now that it's there and IT can get their handle around and give it to them, I think developers are going to, focus back up on the stack, where these more complex problems are actually being solved.
Well, exactly.
Yeah.
And I think it's partly Kubernetes' aim to take the infrastructure away and make it simpler. And, I used that phrase operator earlier. That's a sort of canonical way of deploying things onto Kubernetes. Nvidia, one of these hundreds of innovations that they've produced, have produced a GPU operator. Now, what would that be for? It's not an application, but for a long time, it's been an issue in the machine learning world as to what version of drivers am I using, and what version of libraries am I using, what version of languages am I using, and how to make sure I have a stable thing for the developer. The GPU operator takes care of that. It puts the CUDA libraries and the NVIDIA drivers all into one set of packages, containers, deploys it onto Kubernetes for you, and you don't touch your guest operating system at all. It's all containerized. It's all there for you. So this is really good innovation. It's really interesting. And you're right. We want the developer to focus up the stack on what is the best machine learning model to use, what are the best tunings to apply to it, what are the best data sets to use to train my model, and how accurate can I make this prediction exactly? Can it be 99% correct? And further to that, as this model goes into production, is it ever going to go stale? Are the types of data that it's going to see in 2021 the same types of data that it sees in 2020? That whole field is called machine learning operations, monitoring our models once they go to production and making sure that we're still accurate, effective. We're still effective. So that's
the other thing I would add to this is that if you're an architect, if you're a cloud architect, or you're a data center architect, you're also worrying about risk, right? You're worrying about, can I actually build an infrastructure that will support this up the stack, right? And so but what VMware has done with this is basically taken the risk out of the equation for the base platform architecture.
Right, right. And, we've been good citizens, I think, in cooperating so well with Kubernetes and adopting it so thoroughly in the platform. And security has been a big deal at VMware for a long time. So we need to be sure that what the developer is putting into production is a secure thing and is well protected. And the whole NSX portfolio from vSphere plays in here, NSXT and that sort of area. The other angle to all of that is once a data scientist, who's usually a statistician, produces a trained model and offers it to pre-production people for testing, can we explain what it's doing? Can we actually describe the choices it's making as to whether David gets an offer of a credit card or not? Because we may have regulators asking us to explain that. Right. And so some of these models that machine learning folks produce, neural network-based ones, are hard to explain. They're very difficult. And so this is an area that machine learning is emerging into, which is I can do a good job of prediction, but tell me as a regulator how you got there. How did you get that answer? And that's a whole field in itself.
Yeah, I've heard stories coming out of VMworld where this has become a regulation issue where they've been subpoenaed going, tell us how this worked, and the operators are actually struggling with how to actually tell them how it works, right? And that you need that reporting and security and everything to track what's actually happening.
Correct.
You can just say it's just math. It's just math.
It's just math. I've heard an executive say, until I can explain the behavior of this model, it's not getting into production. That executive at a financial institution. And there are a lot of techniques for tackling that problem, like finding the key columns in the database that are influencing the most and pointing out those key columns as opposed to other columns that are not influencing decisions, and doing so by analogy. Effectively.
Yeah, so going backwards in time and deconstructing the model, right? To say, okay, these are the heaviest weighted factors.
Yeah. So it's really exciting stuff.
This is a fun topic because we spend a lot of time talking sort of about the big stuff, Tanzu portfolio and VMware Cloud Foundation, and the fact that then these things can help you across any cloud environment. But at the end of the day, it still matters that you have this platform that's tuned for the application types that you're deploying, right? And so the work you're doing really feeds right into that, which is making sure that not only can you have VMware Cloud Foundation run on any cloud, or not only do you have this broad portfolio with Tanzu that allows you to do modern apps on any cloud, but that we're tuning the platform for the application stacks that matter, basically.
Absolutely right. And we need to absolutely get Kubernetes right in both places, because that's going to be the middleware of the future, in the sense of I'm going to be building this nice machine learning model probably on premises, using a controlled environment, maybe even a small environment. But eventually I want to make it pervasive in public cloud, make it available Asia Pacific, Europe, and America. And I'll do that in the public cloud probably. And what I'll transport upwards from on-premises to the public cloud will be the model itself, the set of coefficients that tell me the correct answer, the correct prediction. That's quite a small thing. I'll put that into a container. I'll version control that container and have Kubernetes version control it and make sure it fits into my CI/CD pipeline, and send it to the cloud for deployment, is on the same environment, preferably on the Kubernetes environment. So having an appropriately tuned Kubernetes for those two different environments is going to be essential for us. And, a lot of work going into that.
It's interesting when you talk about event streaming architecture, and then you consider it globally. It's kind of like Akamai cache servers were for websites, when all we were doing was serving up web pages, where now you're serving up event streaming apps that might have to be local because you can't wait for a global response, right? Because you're actually doing intelligent things with that data, and then your app is responding in real time. That makes you worry about a cloud architecture across the globe that'll kind of like Akamai your app out out.
It's definitely
that could have sounded lots of different ways, Eric.
It's definitely
Akamai your app.
A federated world where lots of data feeds are coming into points of collection. Those points of collection are doing their own analysis locally, and then feeding the results to a central point that is summarizing and aggregating all that. So
Yeah.
that applies to the IoT world. It applies to the edge world, where edge is going to be machine learning enabled now too. You know, an example is the cameras at a major store. The cameras are pointing at the cash register to make sure that the goods being swiped across the barcode reader are actually the right goods. You know, that they don't have a fake barcode on them, or that's a real example of machine learning. And that, you know, that you can't do by sending everything back to the data center from the cloud. You're going to have to do that locally. So there's a federated model here. Google came up with a brilliant example, which is, what if we put machine learning on every phone that we sell? And the local user, Justin, who's using his cell phone or her cell phone, their data is analyzed for machine learning locally on the phone, TensorFlow on the phone, and then only the learning points, the coefficients, the model, the parameters itself, of the model, only those are sent to a central location. They're reconciled at the central location, and the updated central model is then broadcast out. And that's called federated machine learning, and that's an amazing field of innovation at the moment. But you can see how this machine learning stuff is going to apply to many different fields.
Machine learning stuff is cool. It's it's taken a long time for it to sort of get to the point that it's at right now, where it's actually, you can see it being very useful. Because it was in the beginning, I think there was a lot of this could be useful, but I just don't know what to do with it. You know, so it's sort of, we're moving beyond that.
It goes actually back to the 1950s to Professor John McCarthy at Stanford, who coined the phrase, you know, coined some of the original phrases. And it went through several winters of discontent in the 70s and 80s and disappeared off the map pretty much. But GPUs and big data were the components that brought it back, you know, the large
and massive ability to massive compute power, right?
Big compute power, absolutely, yeah. So it's seeing another summer at the moment is what's going on. I think it's
for me the transition is the mobile phones and the ARM CPUs that get enough compute power in individual hands to be able to collect all the data in real time, and then give the user back, you know, his ability to interact with that data and make that real time, which all of a sudden that becomes extremely valuable.
And somebody gave me a great example of the value of event streaming. Coming back to that theme, is that, you know, events are firing at the enterprise all the time. And some of those events are discontented users or discontented customers. If you process this event streaming data in real time and respond to Eric or to Justin and say, hey, you expressed a lack of satisfaction with our product 5 minutes ago. We're calling to figure out what's going on, and can we help you, and tell us what the source of your dissatisfaction was exactly. How much better is that than 3 weeks later running a report on a database and saying, oh, Eric had a bad experience a month ago? You know, real-time responding from businesses to events that are happening right now or 5 minutes ago. This is the way businesses want to be. They want to call you right away and say, what is the problem? Let me fix it for you. You know, that's I think what the business benefit of all this real-time eventing is going to be.
Yep. Yeah. Yeah, really, really good. And I love the fact that VMware is taking the complexity out of the lower layers and just letting you run in a current environment or in the hyperscaler cloud environments where, you know, you take that complexity off the table and allows you to deal with something that's manageable up the stack. Because I think that if you look at the number of pieces, if you just try to do it all back from scratch, it's overwhelming, and the risk factor is so high that you're going to have architecture failure. That coming in, you know, and running it just like you did on vSphere, it's just so easy.
The fascinating thing I'm seeing, Eric, is that with event streaming like Kafka, there are these series of records that are firing at you in a very lively fashion, as opposed to a kind of static image in a database. The same language, SQL, is being used to query both. So it's almost like an event streaming system has become a database where I want to find all the events that were discontented customers in the last hour. And I'll query the event stream for that, not the database, which is an amazing joining together of two very different technologies. And actually what you said, taking the complexity out of it by giving programmers or developers or data scientists a familiar language, we're actually doing that with our own massively parallel database, which is SQL based. That's Greenplum. And that's a technology that we got from Pivotal, which is also a big data and machine learning platform as well. So yeah, taking complexity away is the nature of the game at VMware for sure.
Right.
Yeah.
Okay, David, I don't know what's left on the topics.
Yeah, no, I think we want to, I know, Justin, you did a couple sessions for the recent VMworld, and they were both on this event streaming. One was on event streaming, one was on, one was on Kafka and Confluent, one was on ML. Maybe you could just mention those and then tell us what you're up to next.
Yeah, the one that I got very good reactions to was a session on what are my choices for doing machine learning with GPUs on VMware vSphere, and that was ETML, Emerging Technologies, Machine Learning, ETML 1110. That session is recorded and you can get hold of it at the VMworld video site. The one on Kafka was hybrid in the hybrid cloud track, and that was 1167, HCP 1167. So that will tell you about our experiences with Kafka and deploying it using the Confluent operator on VMware Tanzu. And I co-spoke there with an architect from Confluent, Jeff Bean, who describes Confluent and Kafka in great detail in that one. So those are good references for you to check out these ideas. Thank you, David, for mentioning it.
What's next for you? What's coming up? Projects or things that are interesting?
Well, there's a whole series of things to work on with Nvidia, and I'm very excited about that. That GPU operator that I mentioned is something that we'd love to take out there and put some rigor into it on vSphere and make sure it works. And we're already testing that multi-tenant GPU, multi-instance GPU technology in the labs. Our customers will be seeing that early next year. So these are exciting things for me, and all of those applications or application frameworks and containers and Helm charts that are built into the Nvidia GPU cloud, we're going to be working closely with Nvidia on that. So I'm very excited about all that work.
Cool. Very cool. All right.
All right. Well, Justin, as always, it's always fun to get some time with you. I could pick your brain forever. I'm looking forward to where ARM goes and where Project Monterey goes, and just all of the machine learning that's coming down the pike. Very exciting. And from an architecture perspective, I think there's going to be some interesting innovation that continues to come out of this whole space, and I think it's just all red hot right now.
It absolutely is. And thank you for the opportunity again, Eric and David, for some time to talk about this with you.
Yeah, thanks for coming on. It was fun.
All right. Thank you very much, as always. Justin, thanks. David, thanks. We'll see you again.
Take care, everyone.